Okay, eighth grade, when we simplify expressions, we need to combine or add like terms. And terms are alike if they have two things in common. They need number one, the same variable, and number two, the same exponent. If the term has the same variable and same exponent, we can combine them or add their coefficients. And so look here, number one, we have 6x plus 7 plus 5x plus 2. I'm looking for terms that are like. Well, my highest exponent I see is 1. How do I know that? Well, look at this term 6x. 6, of course, is the coefficient. It's the number in front of the variable, the number being multiplied by the variable. X is the variable, the unknown number, and the exponent is 1. Well, you may say, I don't see a 1 there, Mr. Roper. Well, you're right. When the exponent's 1, we don't write it. We could have 6x to the first power, and that would be acceptable. But normally in mathematics, when the exponent's 1, we simply just don't write it. It's understood to be there. And so you could say it's there, it's just invisible. So this is 6x to the first power, and this is positive, right? It's because the plus sign's a positive sign also, positive 5x to the first. And so we would say this term, 6x, and this term, positive 5x, those terms are like terms, right? They have the same variable x and the same exponent 1. And so if they are like, we are going to add their coefficients. So we're going to add positive 6 and positive 5. So what's 6 plus 5? That's 11, right? So I'm going to write 11. And I'm going to keep the variable. The variable is x. That's what I keep. I keep that. And I keep the exponent. So the exponent's 1. I could write 11x to the first power, or I could simply just say, hey, I know it's there, it's just invisible. So 6x plus 5x is 11x. Now I need to add my constants. These are called constants. 7 and 2 are constants because they have no variable. And so as you saw with 6x and 5x, I used shapes to combine the like terms. This just gives me a visual to show me that 6x and 5x are like. They are like terms and therefore can be added. I'm going to do the same thing with these constants. After I use boxes, I'm just going to use circles. I'm going to say that positive 7 and that positive 2 are like terms because constants are like terms and can be combined. So as you can see, the sign in front of the term always goes inside the shape. That way you know whether it's positive or negative. So I have positive 7 and positive 2. Well, if I combine those or add them together, what's 7 plus 2? That's 9, right? So I'm going to write plus 9, right? Positive 9. And so this is my final expression, 11x plus 9. That is the simplified expression. I cannot combine those, right? Because 11x has an x in it. 9 has no x. It has no variable. And so therefore, these are not like terms and cannot be added together. So this right here is my final answer, and I will circle my final answer on my paper. Okay, let's go to example number 2. Example 2 down here, we have negative 6m plus 10 minus m plus 2. I'm looking for terms that are like. Well, I see the variable is m, and I have a negative 6m. I'm going to put that in a box. And here I have a negative m. Now, if I do this, if I just put a box around the m, that's incorrect. I should not do that. You see that negative sign in front of the m? That negative sign right there needs to go inside the shape. That way you know this is not m, this is negative m. And so if I were to ask you what number is in front of m, and if you say negative, you would be wrong. All right, negative is not a number. What number is in front of m? Well, if you don't see it, there's an invisible 1 right here. Invisible 1. So this is like a negative 1 in front of the m. Okay? And so these have this negative 6m and negative 1 have the same variable, m, and the same exponent, right? The exponent is 1 because you don't see it. It's invisible. It's up there. It's m to the first. And so since these are like terms, I can combine them or add them together. So I'm going to add their coefficients. And of course, the coefficient is the number in front of the letter, the number being multiplied by the letter. So I have negative 6 is this coefficient, and negative 1 is this coefficient. Okay, so I can remember my signs for adding integers with the same sign. I go same signs, add, keep the sign. So negative 6 and negative 1, that would be negative 7. And then I keep the variable, m, and I keep the exponent, which is 1. And remember, when the exponent's 1, you don't need to write it. So negative 6m minus 1m is negative 7m. Okay, move on to my constants now. So in my constants, I have this constant, 10. I'm going to use circles now. I just used boxes. I'm going to use circles now. I have a positive 10 and a positive 2. Again, notice how the sign goes inside the shape. That way you know that the term is positive or negative. In this case, it's positive. So I have positive 10 and positive 2. Well, what's 10 plus 2? That's 12, right? Or positive 12. So I'm going to put plus for positive, positive 12. Okay, so there's my final answer, negative 7m plus 12. Again, these are not like terms because this term has an m in it, and this term has no m, has no variable. So this is it. That is the simplified expression, circle final answer. Look up here at number 3. Okay, number 3, I have 2n squared. Notice when the exponent is 2, the exponent, that number in the top right-hand corner of the variable right there, when the exponent is 2, you can say squared. So 2n squared plus 11n plus 4n squared plus 7n squared. So I'm looking for terms that are like. Well, all of these have an n in it, right? N, and n. They all have an n. So they have the same variable, but do they have the same exponent? Well, I'm looking here. This has an exponent of 2. That has an exponent of 1. Exponent 2, exponent 2. So I see that 3 terms are like terms. This term, 2n squared. This term, 4n squared, positive 4n squared, and this term, positive 7n squared. These are all like terms because they have the same variable n and the same exponent 2. So they're n squared terms is what we would say. And so if they're like terms, I'm going to combine or add their coefficients, the number in front of the variable. So this is a 2, this is a positive 4, and this is a positive 7. I'm going to add those coefficients. So what's 2 plus 4? That's 6. And 6 plus 7, that's 13, right? So I'm going to write down 13. And what do I do with the variable in the exponent? I keep it, right? These are n squared terms. So this is 13 n squared. Okay? Now, as you can see, all I have left is the plus 11n. Do you see any other n to the first terms? You should say no, right? I don't. And so I can't combine this with anything. So all I'm going to do is I'm just going to draw a down arrow here. I'm just going to bring that term down. This is a positive, so plus positive 11n. Positive 11n. Is that my final answer? Yes, it is. Yes, it is. I'll circle final answer. Okay, because this is an n squared term, and this is n to the first. So they're not like terms. They have the same variable, but not the same exponent. So therefore, they cannot be combined. This is as simplified as you can get for number 3. 13n squared plus 11n, final answer. That's what I circle. Okay, last example here, number 4. I have 6m squared minus 21 plus 13m plus 15. First thing I'm going to look for is like terms. I see this has an m in it, variable m. This has an m in it. But do they have the same exponent? This is m squared. This is m to the first. So they're not like terms. And so if I look at this term right here, 6m squared, I see no other m squared terms. And so it can't be added. It can't be combined with any other term. So I'm just going to bring this term down into my final expression. 6m squared. Now, as you can see, when the exponent's 2, I'm saying squared. Next, I'm going to look at this term, positive 13m, and I'm going to look for any other m to the first terms. I don't see any, right? This is the only m to the first term, and so I'm going to do the same thing as well. I'm just going to bring it down. This is positive 13m, positive 13m. My last step would be to combine the constants. I see this constant, right? It has no variable. Is this 21 or negative 21? Well, to determine that, I need to look at the sign in front of it. It looks like a negative sign to me. This is a negative 21. What about this constant? It has no variable, that's why it's a constant. Is this a positive 15 or a negative 15? Well, again, I look at the sign in front of the 15, and to me it looks like a positive plus sign, right? So this is a negative 21, This is a positive 15. They're both constants, so I have no variable, and I can add constants. I can combine constants. And so this is negative, this is positive. So I wouldn't say same signs add, keep the sign. I would say different signs subtract, keep the big guy, or keep the larger. So different signs subtract. 21 minus 15 is 6. Let me write this in black like the others. 21 minus 15 is 6. And after I do different signs subtract, of course, I keep the big guy sign. So if I have 21 negatives and 15 positives, well, what do I have more of? Do I have more negatives or do I have more positives? I have more negatives, right? And so I keep that negative sign in my answer. So negative 21 plus 15 is negative 6. And this is my final answer right here. 6m squared, 6m squared plus 13m minus 6 is the final answer. I cannot simplify it any further. The last thing I want to point out here is I want you to notice how I am writing my final expression in what's called descending order. Descending order. Now, if you descend, of course, you go down, right? You go down if you descend. And so look at my answer here in number 3. Do you see how my exponent's 2, then my exponent's 1, and I don't have any constants, but if I did, I would write the constant last. Here in number 4, exponent's 2, exponent's 1, it's invisible right there, then I have my constant. So as you can see, in the final expression, the constant is always written last. 9 in number 1 is the constant, 12 here is the constant. I have no constant here, but if I did, it would be written last, and my constant here, negative 6, is written last. So in my final expression, my exponents should be written in descending order from highest exponent to lowest exponent.